Hello, everyone. Welcome to our Oracle AI database series that will be taking place every first Monday of the month at 10 a.m. Pacific Standard Time, unless it falls on a public holiday. In this session, you'll learn about product-grade AI agent development by integrating Google Vertex AI with Oracle AI database on Oracle Database at Google Cloud. And now I would like to introduce Tammy Bednar and Leo Alvarado as our two main presenters for today. So over to you, Tammy and Leo.
Thank you so much, Ernesto. Really appreciate that. So we're going to talk about multi-cloud today, and I know you want to get to the meat and the heart of building AI agents on Google Cloud. But first of all, I wanted to kind of level set everybody on multi-cloud and the benefit of multi-cloud. So I think we know by now that we have seen 98% of our customers are using two or more clouds, and some are using three and four clouds. And I know why. It's because you want choices. You want to be able to have faster innovation with all the best of the clouds. You want to be able to improve your business resilience, reduce risk, lower costs, and also, of course, regulatory compliance always comes into play. But I think the biggest reason about multi-cloud is the choice, your choice and flexibility to deploy the workloads where you need them. And with multi-cloud solutions that we introduced well over 5 years ago, you are able to do that today. You can run your Oracle workloads on premises, and I saw in the poll that many of you are still running your databases on premises. And then we have the hybrid cloud that allows you to run connected to the cloud, but having the hardware in your data center or on premises in a certain region or location. And now with multi-cloud, you're able to experience the same full Exadata cloud automation, their features and performance, whether you run them in Oracle OCI, whether you're running them in Azure, AWS, or Google Cloud as well. And the great thing is you can use your existing cloud vendor credits, or we also have multi-cloud credits where you can have a contract from Oracle and use those cloud credits in any cloud that you want to run your workload in. Now, the most important part of this whole solution is because you're able to have your database and your applications that are important to the business in very close proximity, giving you sub-millisecond latency. And that's very important for a lot of applications. Okay, so very quickly, what's the unique value of running Oracle database multi-cloud? So let's compare that. Let's take a look at a few options of what makes us unique and how you can get the benefits of running an Oracle database at Google Cloud. So first of all, of course, we have Oracle 26 AI. It has all the modern data types built in. Whatever applications you want to run or develop, you can use those using Oracle Database 26 AI. And then we have our Exadata platform. It's offering extreme performance for any of the workloads that you want to run. We have real application clusters and high availability because we know that's important today that you can afford to have downtime to your applications. Security is very important running in the cloud. You want to make sure that you secure your most valuable assets, which is your data. And of course, we have autonomous database. For those of you that are looking for brand new developed applications, our Oracle Autonomous Database is a fantastic platform that gives you the ability to have all these tools in the cloud and ready to develop those applications. And most importantly, developed or delivered, I should say, at the lowest cost. I know it's Oracle, and yes, I'm telling you it's true, guys, lowest cost. So just to recap, the Oracle 26 AI database, we have all these features, all these different data types. Now, the most modern data types that you want to develop your applications in, they're available in 26 AI database. It's going to support whatever workloads you may have, whether it's AI, machine learning, IoTs, analytical, OLTP, whatever workloads you want to run, you can use the 26 AI database to run that. And then, of course, we have all the tools available to you. We have Application Express, ORD, SQL CL, and of course, MCP servers. I know there's been a lot of excitement around MCP servers and agents. And over the course of a few months, we'll be having a lot more conversations about how you can use these MCP servers with Oracle Database 26 AI as well. We have all these developer interfaces available, your favorite interface, and you can use whatever interface you want to get the same results. And as I said, this is my favorite part. I've always said it runs wherever your workload is. Your flexibility, your choice of where you need the workload, you'll be able to run that. So the Exadata platform, this is our next generation of intelligent data architecture for multi-cloud. Actually, Exadata platform started well over 17 years ago as a converged system. And it wasn't just hardware and the database slapped on. We actually did a lot of work to make this a highly performant, reliable platform for your workloads. We made it very data optimized, make sure it's scaled out. We're using the latest technology, and when it comes to networking and storage. And then, as I said, we didn't just slap on the database into hardware. We actually worked the hardware and the software, the database software together to create unique algorithms to deliver extreme performance. We've had a lot of experience at Oracle on your workloads, understanding how workloads work to produce these algorithms that we understand a lot of the workloads to give you the best performance. No matter what workload you're running, AI, analytics, OLTP, mission critical workloads, it can all run on Exadata in the same database even. And as I said, engineered to run wherever you need it. So now with, of course, as I said, as I started off in multi-cloud, you could run get your same experience no matter which cloud you want to run your workloads in, whether that's with Oracle Database at OCI, Oracle Database at Azure, Oracle Database at Google Cloud, and Oracle Database at AWS. We co-locate the Oracle Exadata hardware in the data centers with our multi-cloud partners so that you can experience that same performance that you may be running on premises today. But being able to lower the latency because the database and the application are more closely located together. So really, if you're running applications on premise, you can move them to the cloud, move your application. You don't have to do any application changes. And we have a migration tool to help you migrate called zero downtime migration to help you migrate those workloads to the cloud as well. Now, I said that high availability is very important because we really, in our today, there's no downtime, right? Everybody needs applications all the time. And we know how important that is. So one is the application's always running during maintenance time loads, but also you want to be able to run those workloads wherever you need them, and think about where there could be outages to protect your business from it. So what this represents is the ability to run your primary databases in your partner cloud, let's say Google Cloud, and then be able to have a standby and a backup in the OCI region. So you're expanding or adding insurance into your workloads, into your data to make sure they're always available no matter what kind of outage you have. And the blueprint that we have for you to follow is called Maximum Availability Architecture. There's a whole documentation dedicated to the MAA blueprint. There are lots of white papers and content that's available today on how you can set up or architect your workloads, your databases, and your applications for high availability. If you have any questions about that, reach out to Leo or I. We'll be happy to get you the information that you're looking for. And then when it comes to backup, so backup recovery plays a very important part as part of high availability, but also protecting your data. And that service is called Zero Data Loss Autonomous Recovery Service. This is near and dear to my heart because it uses Recovery Manager or RMAN for your backups, but then it adds a lot more intelligence into the service to give you real-time transaction protection with those very critical applications and workloads. And then we always continuously recover or validate that the databases can be recovered, that your blocks are recoverable. So I started in support many years ago, and it seemed like every other day I was opening up a ticket for block corruption. I haven't seen block corruption in years because we do a lot of work to validate your blocks and your data as it's being backed up with the autonomous recovery service. Also, we know that we want to make backups low impact against production environments. It's important to back up, but we want to make it easy and so that it doesn't take a lot of the resources to do the backup. So with recovery service, we take one level 0 backup, and then after that, it's only incremental. And then most importantly, ransomware resiliency. Unfortunately, in today's day and age, we've seen ransomware take rise within the industry. And with recovery service, it can help you with that ransomware resiliency. We always encrypt the data. We encrypt the data in the database itself. We require all the data to be encrypted when it's in the cloud. We encrypt the backups as well. We have a logical air gap between you and the Oracle Cloud Operation tenancy. So that's how we also help with ransomware resiliency. So stay tuned. There's a lot more information coming out over the next few months about autonomous recovery service and resiliency with your data and your workloads. So I talked about high availability. Security is another one of those topics that is very important to keep your data safe. And we've always had a database security, and we've made it transparent so that you didn't have to change the applications, but you could implement your security for your databases or your data itself. We have a service called DataSave. It's a free service that's available with your cloud databases that help you find sensitive data to protect that. It can help you audit and things like that. So, that's one of the tools that we've also given you for as well to look at your data. But as you can see, multi-cloud is no different. We've always used the term defense in depth with security. It's always about where are you doing the protection? Where else can you do the protections of your data? Whether it's authentication, whether it's encryption, whether it's Oracle OCI Vault, whether it's using key management, using one of the database services or database security features to be able to control who's accessing the data. Are they really valid users to access the data, etc. So we've done a lot of work as well around security to give you that defense in depth posturing to protect the data as well. The autonomous AI database is going to deliver your best database experience, especially when you're developing brand new applications in the cloud. It can run any kind of workload that you need. Plus, it runs on the Exadata platform to give you that performance, and then it has a lot of built-in automation, best practice, and tools to help you deliver or develop that application as well. And what autonomous AI database has done is removed a lot of the manual tasks that we have learned over the years, how we can automate those, implement best practices so that it frees you up to really focus on the data and the applications themselves. And I said at the very end at one of the slides that we can deliver lowest cost. And I'm telling you, it's true with Oracle. We have a lot of capabilities that lower costs for your database on multi-cloud. So we lower deployment costs because we build and operate the Oracle database engine. We have the team that understands how to build all this functionality. We don't charge for a high IOP performance on the Exadata platform, and there are support rewards that reduce support costs for on-premise licenses as well. When it comes to subscription cost, we have the lowest cost for what we call the Oracle database license included, that gives you all the features that are in the database. You have them available to you when you need them. And then on the right hand side in that little box, it shows you all the different options that are included for free as part of your Oracle database licensing as well. And then you have bring your own license. We know that many of you are still running on premises, looking to move to the cloud. Those licenses can be used within the cloud as well. Okay, so you have two options when you license your database. So these are the database service options. I said we have lots of flexibility, lots of options where to run your workload, and we give you also lots of options of which service to use based on the workload and your applications that you're running. We have our autonomous AI database. It's fully managed, cloud native Oracle database running on Exadata platform, and it has that complete automation. And we removed a lot of those manual tasks. That's going to give you lowest total cost of ownership. Then we have our Exadata database service family. We have two different options in Exadata database service. You can even have a dedicated option where all the hardware is dedicated to you, or we have the Exascale infrastructure option, which is a shared architecture where you spin up a VM cluster and we pool all the resources on the Exadata platform. This Exadata infrastructure option gives you the ability to create or provision smaller workloads running on the Exadata platform. So Exadata database service, co-managed, Oracle database service running on Exadata platform, cloud automation, full administrative control. Then we have our base database service, which is also a co-managed Oracle database service on a shared infrastructure. You spin up a VM, you provision a single VM with a single Oracle home and a single CDB. You can have lots of PDBs, but it also comes with a lot of cloud automation and has full administrative control. And then I've already talked about our autonomous recovery service, fully managed zero data loss recovery using real-time transaction protection, incremental forever backups, and continuous recovery validation. So lots of flexibility, lots of choices for you to get started in Oracle Database at Google Cloud. So now I'm going to turn this over to Leo, and he's going to get to the heart and the meat of this presentation.
Okay, so now we have seen how Oracle AI Database brings AI right into the heart of your mission critical workloads. But here's the question that I get from customers all the time, like, hey Leo, we already invested in Azure, Google Cloud, or AWS. Does that mean that we have to choose? Well, the answer is no. So Oracle Database at multi-cloud means you get the full power of Oracle's database running natively on your cloud of choice. So providing you with direct low latency access to your hyperscaler native services like AI analytics and data services that you are already using. And managing the Oracle database in your cloud doesn't mean learning new tools. So you provision, monitor, and manage right from your existing hyperscaler portal using the same hyperscaler APIs, providing you seamless experience and that you can manage resources in hyperscaler portal through integrations. And the infrastructure is physically segregated for security with fine-grained access controls and federated identity built in, and that you'll have close physical proximity of your Oracle AI database services to hyperscaler compute, application, analytics, AI services that gives you low latency, high bandwidth, which is crucial for most of your applications. And then complementary service to your Oracle AI database services, you also have your OCI Golden Gate, which is a managed service. It's a fully managed solution for high performance and data integration and replication. Okay. So the real opportunity here is what happens when you connect business data in Oracle with the native AI analytics, or even container services in other clouds like Azure, AWS, and Google Cloud. So you can easily train your models in Azure AI Services, AWS Bedrock, Google Vertex AI, using real-time data coming from your Oracle Autonomous AI database without the need of replicating or duplicating the data or even compromising governance. And you still have access to the OCI services when you run Oracle database at multi-cloud services, as we maintain fast private networking between their regions and ours for control plane access that can also be used to access and integrate with OCI, AI analytics, and data replication services. So you can really pick and choose your hyperscaler and services and connect any or all of them to your Oracle AI database to innovate with fresh business data that keeps your architecture and security model simple, consistent, and strong. So let me walk you through with a couple of use cases. So first up is it's an AI assistant for a product search to assist with product searches based in companies product or service catalog using semantic searching enabled with vectorization of catalog data and users input search. So instead of the basic keyword matching, so we're using Oracle AI vector search, all powered by Oracle database at Google Cloud, together with Google Vertex AI to understand the customer intent. So this could be a user or a buyer can describe what they're looking for in a natural language, and then the assistant returns semantically relevant results matching on the intent, images, categories, and characteristics, and not just exact words. And that we bring in the benefits of RAG, or Retrieval-Augmented Generation, provides, like not only exact keyword match or similarity search results, but also semantic, and that it optimized for top K results based on matching score to increase result relevance to the user, improving satisfaction with results and likelihood of purchase and repeat transactions. So here's the flow on how AI vector search in Oracle AI database powers a complete Gen AI pipeline using retrieval augmented generation, or RAG, with your enterprise data. So the user enters a natural language prompt to the AI assistant or chatbot to start a product search. So here you'll see that it just asks for a European vacation for two adults that includes beach time, bicycle tour, some exploration, and then it gives the budget of $2,000. And then the LLM vectorizes the questions and requests in order to perform a search for similar matches. And then the vectorization is done using the similar embedding algorithm as the product catalog that has been vectorized with already. And this aligns the user's prompt with the results most likely to match it. And that vector embeddings may be done using any of the many tools available, including the one available within the database. So you can use the Onyx model from within the database to directly generate and store the embeddings in the database, or use AI tools like Google Vertex AI to generate the embeddings first and then store them in the database. Then the vectorized question is then searched using Oracle AI vector search against the product catalog data, or potentially inventory data as well, to find the closest matching items that are also available for purchase and ship it to the user in a reasonable time frame. And then the vector search itself is offloaded to Exadata intelligent storage with the AI vector search feature for parallelized searching across the entire data set on all the storage servers. So only the most relevant results are returned from each storage server to the database servers, optimizing data transfer and data processing required to do a final sort for the top results to send back to the users. And then the user's prompt is then augmented with the search results and sent to the Vertex AI LLM to formulate a natural language response to send to the user with the optimal results from the original request. Okay, and here is the architecture of how you can build intelligent apps using Google Vertex AI with Oracle database at Google Cloud. So this architecture brings together components from both Google Cloud, Vertex AI, and Oracle database at Google Cloud. So let me just walk you through on how they work together to power an intelligent e-commerce RAG application. So starting from the left, a user submits a question to your AI assistant. So this could be a Streamlit application chatbot running on Google Compute Engine within a private application subnet in Google Cloud. And then the question is immediately sent to Vertex AI. So using the Gemini LLM models, so the Vertex AI converts the user's natural language question into vector embeddings. Convert it to a vector embeddings that will be stored on your Oracle AI database. And then these embeddings are then used to query our Oracle AI database on Google Cloud, which stores the pre-generated vector embeddings for our knowledge base, which is your product catalog data. And using Oracle AI vector search, we perform a similarity search to find the most contextually relevant data that matches the user's question. And this is the core of the RAG pattern. So instead of relying solely to your LLM's training data, we're dynamically retrieving the most relevant, up-to-date information from our database based on semantic similarity. And that the retrieved data is sent back to the Vertex AI along with the original question. And now the Gemini model has both the user's question and the specific relevant context it needs to generate an accurate, informed response. And finally, that enriched response flows back through the chatbot or your AI assistant to the user, delivering an answer that's not just AI generated but grounded in your actual data and context. So the next slide is the demo that we have built for you. This is deploying a RAG application using Oracle database at Google Cloud.
Let's start by taking a look at our Oracle Exadata database service running at Google Cloud. Here in the Google Cloud console, you can see we have provisioned an Exadata infrastructure, which gives us the enterprise-grade performance and scalability we need for production workloads. Now let's look at our VM cluster. This VM cluster provides the foundation for our Oracle AI database that will power our RAG application. Let's find our connection information for the database where we have the product catalog already populated. Leo, can you explain the next component of our architecture?
Sure. Here we are in the Google Cloud's Vertex AI, specifically the model garden. And this is where the magic of generative AI happens. In the model garden, we have access to a wide variety of foundation models. Here you can see Gemini 3, Imagen 4, and also Veo 3. And that we also have access to various task-specific models like image classification, object detection, image generation, text generation, and many more. For our RAG application, we will be using the text embedding models to convert our product descriptions into vector embeddings that we can store and search in our Oracle AI database.
Now, let's look at the code that brings this all together. Here is our Python application that connects Oracle database with Google's AI services. First, we establish our database connection using the Oracle DB library. Then we set up our parameters for the embedding model. we are using Google's text embedding 004 model with a semantic similarity task. And we are generating 768 dimensional embeddings, a good balance between accuracy and performance. Here is our embed text function that generates text embeddings using Google's Vertex AI. This function takes our product descriptions and converts them into mathematical vectors that capture the semantic meaning of the text. These embeddings allow us to perform similarity searches, finding products that are conceptually similar even if they don't share the exact same words.
Hey Vishal, let's verify our data is loaded correctly. Here in Oracle SQL Developer, I'm running a few queries against our product table. We have 6,000 products in our database, and we can see that all products have their title embeddings populated. And here's a sample query looking for summer vacation package. So this shows our traditional text-based search capability, but in a moment, we'll see how much powerful vector similarity search can be. And now for the exciting part, semantic search in action. So when a user asks a question like summer vacation package, we convert that query into a vector using the same embedding model. And then we use Oracle's vector distance function to find the products whose embeddings are closest to the query embedding. And watch how the database returns relevant results ranked by semantic similarity, not just keyword matching. This is what makes the search feel intelligent and contextual. Now that we have seen semantic search, what's next, Vishal?
Next, we enhance our application by adding conversational AI capabilities. This is where we are implementing the full RAG pattern. This prompt is sent to the Gemini model through Vertex AI. The model uses the retrieved context to generate a natural conversational response that's grounded in our actual product data, preventing hallucinations. Leo, can you walk us through the RAG application we have for this?
Sure. Let's see our RAG application in action. This is my Travel Dash, a personal travel companion application that demonstrates how RAG transforms the way we interact with data. Let's try a search. I'll type, find me a 5 to 7 day European vacation for 2 adults. That includes some beach time, some exploration, a bicycle tour, food tour, and my budget is $2,000. Notice this query, it's completely natural language. I'm not using any keywords or filters. I'm just describing what I want, like duration, travelers, activities, and budget. So behind the scenes, here's what's happening in the RAG pipeline. The query goes to Google Gemini, which converts my natural language to vector embedding, and then Oracle AI Vector Search performs a semantic similarity search against our travel package database. Oh, and look at what it returns. Amsterdam. Notice how the response isn't just data from the database, it's understanding my needs. Okay, so let's see the results. So it highlights the bike tour, which I specifically asked for, and explains why. Yeah, Amsterdam is the bike capital of Europe. Okay, cheese and soup waffle food tour, matching my food tour request. And the price within my budget. Now, let me refine my search. I'll ask for another option, maybe more beach time. Nice, Barcelona. And notice how it compares it to the first option. So it's maintaining the context from our previous conversation. Let me add one more constraint. I mentioned I'm on a budget. The vector search will now prioritize packages that are cost-effective while still matching my regional requirements. Wow, Lisbon. And look at this. It shows me the cheapest of all 3. Okay, so still has the bike tour, food tour, beach access. Plus you're saving 150 from your budget. Wow, it's doing the math for me. Okay, now I cannot decide. Which one should I choose? I'll ask it to help me compare these options. And look at this analysis. It's comparing all 3 packages across multiple dimensions. Bike tours, food beaches, value, duration, and even ranking each option with gold, silver, and bronze, and making a personalized recommendation based on my original query. And it remembered the detail from the very first request and weighted the recommendation accordingly. And this is the power of RAG, combining vector similarity search in Oracle database to find relevant products. And product details and context are pulled from the database. And for the output, Google's Gemini model generates natural, helpful, and personalized responses.
Okay, but here's where it gets even more interesting. So that RAG demo was powerful, but think what happens when your customers' needs get more complex. So imagine using the same example, like Jane is booking that European vacation and asks, like, I have a severe nut allergy. So like which packages are safe for me? So that's not just a search problem anymore. So that requires reasoning across multiple services, and that's where the AI agents come in. So you can easily create specialized agents for different personas. You can call different tools as well as to call different functions orchestrated together to answer questions that a simple search never could. So you can easily enhance from a RAG to an agentic RAG to solve RAG limitations with agents. And here's the sample architecture in which we're using the same RAG flow, but this time we're evolving it to an agentic RAG. So in the left from your application, so it's calling an AI agent built using the ADK available on Vertex AI. And then you can call several tools or functions like when we introduce a new constraint, like the user, like Jane. So she wants to know, and she told the prompt like she had allergies for peanuts. So you can have another tool or service that will go through like another a separate table with travel profile that will address that additional constraint. And which leads me to our second use case on how you can easily build AI agents using Vertex AI, using ADK with Oracle database at Google Cloud. So the first step is to install all the dependencies. So before you start when developing your agent, so what do you need before starting? So again, you need to have your Cloud Google project with Vertex AI API turn on, and then of course your Oracle database at Google Cloud. So if you wanted to connect to an Exadata database service on dedicated, then you must have your Oracle Cloud infrastructure and Cloud VM cluster, CDB and PDB provision for your Oracle AI database 26 AI. So first step is to install all the required packages so you can spin up a Google Cloud Workbench instance running in the same region as your Exadata Cloud infrastructure. And then the second is to configure and establish your Oracle AI database and Vertex AI credentials. So here, this is where you set the Exadata database service connection parameters. And before you build your agent, so you need to confirm that your Workbench notebooks can reach your Oracle AI database, which is on your Exadata database service. And then next to it is to define the required data models and tools or functions. So here, since we are addressing another constraint, which is the food allergy of the customer or traveler. So we might create several tables, like a traveler's table, which contains the traveler profile. You can have another table for bookings and also the travel packages. So on your on your agent, so your food allergy data can be stored on a traveler profile as a JSON array that can cross-reference against travel packages or allergy safe options, and that the agent can call the get traveler profile to retrieve allergy info and then find allergy safe packages to match the safe packages, keeping safety checks as an explicit mandatory step rather than just an optional filter. So here you also have another service for finding the allergy safe packages, and then another service for getting the full travel package details, in which it retrieve complete details for specific travel package by its based on the user's profile when the traveler asks about specific package to verify allergy safe option. And that you can even add a tool or a function calling AI vector search if you want to ask semantic questions about a certain product. So here, it even recommended a product like a waterproof hiking boot to the same travel package inquiry. And then next is to create the agent. So this is where you define the agent multi-step reasoning flow. And that here you have like 5 different tools that your agent can call based on the decision on the instructions that we will provide the Gemini model. So here we're trying to create an agent, like a travel package recommendation assistant that is aware of the traveler dietary needs, food allergies, booking history, and package compatibility. And that the instruction block tells Google Gemini exactly how to chain the tools together in a logical and safety first flow. So here on your agent, you're just providing instructions to your to Gemini. Like first is to find the traveler. So this could be a prompt mentioning the name or email of the traveler, and then it checked for allergies first, which is mandatory. So this is calling the get traveler profile service to retrieve the traveler food allergies list. And then the third one is to find the safe packages. So as long as it passed the full food allergies list from the profile, and then it will be able to call on the find allergy safe packages. And then you're calling another service, which is to verify before confirming. So if recommending a specific package, so before calling that get package details, you need to be cross-checked with all the allergy safe options against the traveler food allergies before giving a final recommendation. And that you can have another service where you have your booking history that will be called when asked about past trips or upcoming travel for that particular traveler. And then you'll see here some of the additional instructions that you're providing uh to Gemini. So it says like never recommend a package without verifying its allergy safe options, and that after it gone through all the instructions, the Google Gemini decides which tool to call for your inquiry. It could be searching travelers, get traveler profile, get traveler bookings, or find allergy safe packages, and so on. So after you've created the agent, so the next is to run the agent. So this is just creating a session and running the agent. So it includes a simple loop so that you can send multiple queries to your agent, and that each query runs the full ADK reasoning cycle. So Gemini decides which tool to call, and that your Oracle AI database will execute, and then the result grounds the final answer. So that's how easy you can develop agents using Google's Vertex AI ADK, which, but here's another use case, our third use case, like if you wanted to connect your created agents to your enterprise systems, so you can also call or introduce another service, which is calling an MCP server. And then for Oracle, we have released an MCP server for Oracle database. So Oracle MCP server for Oracle database. So think of it as a personal assistant for your database. So a user makes a request in plain natural language through an MCP client like Cloud Desktop or VS Code, and then the AI interprets it, and that it generates the SQL, and that the MCP server executes it against the Oracle database, and then the results come back in natural language, no SQL expertise required. And this This unlocks value for everyone. Like your business users can get a self-serve reporting and forecasting. Your DBAs can automate maintenance and security analysis through conversation, and that developers can now easily debug, tune, and document code faster than ever, all through using your existing access path and security policies with full auditability of every AI interaction. And that AI is not just for developers. And today's modern LLMs, they're also great at working with Oracle via SQL, PL/SQL, and its APIs. So if you're building AI agents on your ADK, you can easily create another service or function which your agent will be calling the Oracle MCP server for you to connect your enterprise systems database to your AI agents. So let's imagine a few scenarios together, like what so that we can see what's possible with your existing Oracle database and your favorite LLMs. So here, as a business analyst, so you can use MCP to assist with data analysis, pattern discovery, and remediation suggestions. So here, the analyst prompts MCP using the natural language shown to perform the desired analysis and share the key findings as well as displays the hotspots on the map. So the plotting here leverages Oracle spatial capabilities to translate geo coordinates to map locations for easy human understanding, and that the MCP server formulates and executes the necessary queries on the user's behalf and generates an HTML page to display the findings and results. So on this example, so here an analyst asks the MCP server to help with forecasting potential business impacts regarding supplier interrupts. So same thing. The MCP server formulates and executes SQL queries against the Oracle database, looking for items with only a single supplier, as well as those with low current stack across the organizations. And then it quantifies the findings in key findings and goes on to suggest immediate recommendations. And another example is like here we see that the MCP server can help improving DBA efficiency for Oracle databases. So first, instead of DBA spending hours manually searching for performing issues, so now they can just use a simple natural language prompt. Like they might ask, find the worst performing query in the last 2 weeks and suggest optimizations. So the MCP server takes over from there. It automatically connects security to the Oracle database, writes and runs multiple SQL queries, and collects all relevant performance data. So you'll see here that the MCP server reduces manual work and lets DBA focus their expertise where it matter most. So leading to faster resolution, fewer bottlenecks, and an overall boost in database performance and team productivity. And with that, we've seen the how you build a RAG application combining Vertex AI and Oracle database at Google Cloud. We've seen how you can easily develop agents using ADK interacting with Oracle database at Google Cloud. And then for the last use case, even extending it, calling out an MCP server for your Oracle database. And with that, I'll be handing it over to Tammy.
Thanks, Leo. That was a lot of great information. So, with our multi-cloud solution, we are really expanding our footprint to make it not only your choice of where you want to run your workload, which service you want to run your workload on, but also lots of great choices of where the regions are for the availability of these services. So as you can see on Oracle Database and Azure, we have 33 live. At Google Cloud, we have 12 live, 5 more planned. And at AWS, we have 5 live and 17 more are planned. And next slide, Leo. And we have a great website that stays up to date, that gives you the latest information on all the different services and also which regions are available as well. So if you go to that URL at the bottom of this slide, you can see all the regions and the services and all the latest updates of what is available. Next slide, please. So, Leo ran through that all this great work. So our key takeaway is that we want you to run Oracle AI database workloads anywhere with the full functionality across on-premises, hybrid cloud, public cloud, with OCI and multi-cloud as well. Oracle AI database, when deployed in multi-cloud, has unique capabilities that make it the best platform for all your modern workloads. And data modernization strategies are driving multi-cloud customer momentum. And we're so excited to see all the great functionality that's coming out and all the use cases that we've seen for our customers. So thank you so much for sharing those. And combining all of that with Oracle AI Database and Exadata with the best cloud technologies. So next slide, please.
So thank you very much, both of you, Tammy and Leo, for an awesome session. We really appreciate your time and help, and I hope this was a really good learning experience for everyone. So if you want to learn more, here you will find a few links that will help you or that will walk you through Oracle Cloud and get some hands-on experience, some detailed documentations, link to our Live Lab website, Oracle Learning Library videos and YouTube. And once again, you will have access to these links. If you are thinking about more training for your organization, if you enjoyed this session today and you would like to conduct personalized training sessions for your entirety of your organization, please do email us at our personal training email and we'll reach out to you. Just please remember that personal training is an investment we make in our customers to help them grow and develop their OCI skills at no extra cost to them. Next slide, please. Here we have our Day 1 and Beyond series and upcoming sessions for the month of March. You still have an opportunity to attend a couple sessions this month within multiple different series listed on this slide. Now, our next database session will be next month on April 6th. In this session, you will learn about Oracle security within the Oracle AI database. Next slide, please. So again, thank you, Tammy. Thank you, Leo, for your time today. We really appreciate the help here. I hope you all learned something new. Thanks for joining today's session, and I hope to see you on the next one. Have a wonderful day.
Thank you. You too. Bye.